Right now, somewhere in a Ram dealership, a service advisor is explaining to someone that unlocking their diesel truck's full potential is going to require a $2,000 tuner, a dyno appointment, and probably a conversation with the EPA. And that guy is nodding along and pulling out his credit card. 30 years ago, a farmer in Oklahoma was doing the same thing with a flathead screwdriver and a bench grinder. And he was making more power. This is the story of the Bosch P7100 injection pump, and specifically, the tiny piece of metal hiding inside it that Dodge really didn't want you to find. The last of its kind. Let's set the scene, because the engine this pump lives on matters just as much as the pump itself. The 1994 to 1998 Dodge Ram, the 5.9-liter 12-valve Cummins. If you know, you know. If you don't, short version. No computer controls this engine, no meaningful emissions equipment, 6 cylinders, 12 valves, a cast iron block that weighs approximately as much as a refrigerator, and a mechanical fuel injection pump engineered in Germany by people who clearly had zero interest in fuel economy ratings. From the factory, this thing made 160 to 215 horsepower depending on the year. But here's the thing. Those are factory numbers, intentional numbers, numbers with the handbrake still on. And the handbrake is the P7100. The P-pump, that's what everyone calls it, is a mechanical, inline injection pump. It has no wiring harness, no sensors, no software. It runs entirely on physics, springs, and geometry. And because it runs on geometry, geometry is exactly how you tune it. This is the last time in automotive history that you could genuinely unlock serious power from a diesel engine using tools you already own. How a mechanical diesel actually works. Before we get into the hack, there's one thing you need to understand about diesel engines, and it's something most people get wrong. A gas engine controls power by restricting airflow. You push the pedal, the throttle body opens, more air gets in, the computer dumps fuel to match it, you make power. Lift off, the butterfly closes, airflow stops, power drops. It's essentially a choke valve, that's all it is. A diesel doesn't work like that. There is no throttle body. The intake is wide open all the time. A diesel controls power by controlling fuel delivery only. More fuel equals more combustion equals more power. Less fuel equals idle. The pedal under your right foot isn't a throttle, it's a fuel dial. In the device that controls that dial, the governor is a mechanical computer made entirely out of spinning weights and leverage. No chips, no wires, just physics doing math. Here's how it works. Inside the P7100, there are weighted flyweights mounted on a rotating shaft. As engine RPM climbs, centrifugal force throws those weights outward. As they move outward, they push a mechanical arm, the governor arm. That arm pushes the fuel rack, and the fuel rack is the master slider for every single cylinder simultaneously. Think of it like a master slider. Push it forward, all 6 cylinders get more fuel at the same time. Pull it back, they all get less. It's elegant, mechanical, and brutally simple. Now, how far forward can that rack actually go? How much fuel can it physically deliver? That's determined by one thing: a single piece of stamped steel inside the AFC housing. That is the fuel plate, or the cam plate, or the torque plate, depends who you ask. It's a small piece of profiled steel, held in by 2 ordinary bolts. Its shape, those specific angles, that specific profile, physically stops the governor arm from pushing the rack past a certain point. Think about what that means. At wide open throttle, after the turbo is making full boost, the governor is fighting that plate with everything it has. It wants to bury the rack. It wants to dump maximum fuel into all 6 cylinders. And the plate is sitting there saying, no, this far, no further. That is the wall. The entire diesel performance community spent 30 years figuring out how to tear it down. Here's where it gets fun, because Bosch and Dodge absolutely knew someone was going to try this. When the truck left the factory, the AFC housing was sealed with what are called break-off screws. These are bolts with intentionally weak heads. The factory torques them down to spec, the head snaps off on purpose, and suddenly there's no slot, no hex socket, no grip for any tool, just a smooth metal stub. The whole point was to look at you and say, "You can't get in here, move along." They weren't trying very hard. The standard method is a center punch of the hammer. You drive a T15 Torx bit pattern into the top of the stub. The metal is soft enough that the bit cuts its own socket just from pressure. 2 or 3 strikes and you've got purchase. Alternatively, a sharp chisel at the edge of the head and a few light taps will spin it right out. 4 minutes of work, maybe 3 if you've done it before. Once those screws are out, the housing comes off. And there it is. A piece of steel roughly the size of a matchbox held in by 2 ordinary bolts. This is what all the fuss is about.
The levels. This modification has 3 levels. You pick yours based on how far you want to go and what the rest of your truck can handle. Level 1 costs nothing and takes 5 minutes. Loosen the 2 bolts, slide the stock plate all the way forward toward the front of the pump, retighten. That's it. What you've done is moved the wall back. The governor arm now has more room to push before it hits the limit. More rack travel, more fuel. On a stock engine with the factory turbo, you're picking up somewhere between 30 and 50 horsepower just by repositioning a piece of metal that was already sitting in there. You didn't add anything, you didn't modify anything, you just gave the pump permission to do what it already wanted to do. Level 2 is the aftermarket plate. The stock plate has what the tuning community calls a ski slope profile. It deliberately limits fuel at low RPM and high RPM, tapering the power curve on purpose to protect the drivetrain. An aftermarket plate, specifically the number 10 plate, which is the most widely recommended street profile in the entire P-pump world, has a more aggressive cam angle, more rack travel across a wider RPM band, no governor adjustment required. You can order one online for about $20. Some of these plates have been the same exact design for 30 years because nobody's found a reason to improve them. Level 3 is where it gets serious. This is the 0 plate, ground completely flat, no profile, no slope, no wall. The rack goes wherever the governor wants to take it, full travel, all the time. But if you want to hit the absolute physical ceiling of what this pump can do, you spend $15 at a Cummins dealer on something called the Mac Rack Plug. This is a small plug that replaces the factory rack stopper inside the pump body itself. The stock plug allows 19 millimeters of rack travel. The Mac plug allows 21. 2 millimeters doesn't sound like anything, until you realize that 2 extra millimeters of rack travel unlocks enough additional fuel volume to put you right around 100 free horsepower on a stock engine. 100 with a screwdriver, a bench grinder, and a $15 part from your local Cummins dealer. The star wheel. The smoke dial. While you've got the AFC housing open, there's a second adjustment in there that every P7100 owner should know about. Most people don't touch it. That's a mistake. Under a hex plug on top of the housing is a geared wheel, the star wheel. This controls the spring tension on the AFC diaphragm, which determines how much boost pressure the turbo needs to produce before the AFC lets go and allows full fueling. Stock setting is tight, conservative. The turbo has to build significant boost before the floodgates open. Turn the star wheel toward the engine, loosen that spring, and now the diaphragm responds to much lower boost pressure. Fuel comes in earlier. The turbo spools faster because it's got more exhaust energy driving it sooner. Off the line, the truck transforms. The downside is smoke. Real, biblical black cloud diesel smoke. If you've ever watched a 12-valve hit the on-ramp and throw a wall of soot across 3 lanes, you've seen a turned star wheel doing exactly what it was set up to do. Here's how to think about these 2 things together. The fuel plate is the ceiling. It determines the maximum fuel the pump can ever deliver. The star wheel is the rate of climb. It determines how fast you get to that ceiling. One without the other is half a setup.
Together, they're what makes a tuned 12-valve feel like a completely different machine. Why the factory didn't do this, and why that was the right call. Here's the question every new 12-valve owner asks the first time they hear about this. If it's this simple, why did Dodge leave all that power sitting there? The answer isn't stupidity. The answer is survival. When you add fuel to a diesel engine, you add heat. That's not a design flaw. It's basic combustion chemistry, and heat in a diesel is measured by exhaust gas temperature, EGT, the number that will kill this engine faster than anything else. On a 12-valve Cummins, the danger zone starts at 1300 degrees Fahrenheit. Above 1400, you're at real risk of melting pistons, not cracking them, not scoring the bores, melting them. The aluminum in those pistons will turn to liquid if EGTs hold above critical temperature long enough. And if you've ever seen the photos of a destroyed 12-valve piston, and they're out there, you know this is not an exaggeration. More fuel without more air doesn't make more power, it makes more heat. The factory turbo can only move so much air. Once you hit the air ceiling, any additional fuel stops producing combustion and starts producing temperature. The factory limited the pump not because the pump couldn't do more, but because they needed the engine to survive 200,000 miles of commercial hauling without a pyrometer in the cab. And then there's the transmission. The factory 47RE automatic behind the 12-valve was engineered to survive around 400 pound-feet of torque. That's the number Dodge designed it around. Stock engine makes around 400 pound-feet. Comfortable margin, nothing catastrophic happens. Now, grind that plate flat, turn that star wheel, slide that AFC housing all the way forward. You are now hitting the driveline with over 600 pound-feet of torque at 1600 RPM. Think about what that actually means. The engine isn't building up to power, it's detonating into it. The truck doesn't accelerate, it lurches, it tries to rip itself in half. And the stock input shaft in that 47RE, a piece of steel that transmission builders have been calling a liability since 1996, doesn't slip. It doesn't slip and recover, it snaps, clean, like a dry twig. The factory didn't hide this power to cheat you out of it. They hid it so you wouldn't pull away from a stoplight and leave your transmission lying in the intersection. The last mechanical frontier. Let's think about something here. We live in a world where every extra horsepower is gated behind a firmware revision, a dealer authorization code, and somewhere in the fine print probably a terms of service agreement, where the ECU in your truck is actively encrypted to keep you out, where getting the carb exemption you need just to run legally with an aftermarket tune can cost more than the tune itself. The P7100 doesn't know any of that exists. It doesn't have a USB port. It doesn't have a chip. There is no software to crack, no code to reverse engineer. There is nothing between you and the fuel curve except geometry. And geometry is something you can change in an afternoon with tools from your garage. What we're actually talking about when we talk about this pump is the last moment in the history of the automobile when a regular person could walk into their shop with a bench grinder and $40 and come out an hour later having genuinely and permanently changed the performance character of their vehicle. Not unlocked it through an app, not downloaded a tune file, changed it with their hands using physics. It is not efficient. It is not clean. It will smoke in a way that will offend people, but it is the cheapest, most accessible horsepower that the internal combustion engine has ever produced. And every single person who has ever ridden in a properly tuned 12-valve pulling hard out of a corner will tell you the same thing. The smoke smells like victory. Next week, we go somewhere darker. We're talking about the only diesel failure mode that you literally cannot stop once it starts. An engine that finds an unlimited fuel source and decides to feed itself until it physically destroys itself. No key switch, no kill button, nothing you can do. You already know what it is. The runaway diesel. See you then.